in the diagram, TSR is actually a diameter of the largest circle. This T, this S, and this R, diameter of the largest circle, called TQ of the largest circle cuts the smaller circle at M, right? TQ is a chord, it cuts the smaller circle at the point M there, right? PQ is a common tangent to the two circles at Q, right? So you can see that PQ is this one. It's actually a common tangent to the two circles at Q, right? As shown, RP is perpendicular to PQ, so if RP is perpendicular to PQ, but MS is parallel to QR. MS is parallel to QR. Right. Proof giving reasons that SQ is a diameter of the smaller circle. So you're going to look at the answer to 10.1.1. Okay, 10.1.1. Right, so since TSR is a diameter of the larger circle, it follows that we shall actually have a statement. And for every statement, there has to be a corresponding reason. Right. What is the statement? Well, the statement is that angle Q1 plus angle Q2 is actually equal to 90 degrees. In other words, this angle here is 90 degrees. Why? It is an angle in semicircle. It's an angle in semicircle. Right, so at the end, then you have that angle M2 is equal to 90 degrees. Why? Because you have co-interior angles. Right, the reason why we have co-interior angles is because MS is actually parallel to QR. MS is parallel to QR. Why are they parallel? Because it was given that way. Right, so in other words, the observation is therefore that this M2 is equal to 90 degrees, and therefore SQ, I just erase this a little bit to clean up. You can write a bit clear here. And therefore SQ is a diameter. Okay, why would we say SQ is a diameter? Because of the converse of the angle in semicircle results. Angle in semicircle result. So you have that converse there. Right, so if you look at 10.1.2, you need to prove that so in other words, we have just proven the first one and need to prove the second one. Right, need to prove that RQ okay, goodness me. Continue. Yeah. Right, we continue. We continue. 10.1.2 is next. Right, so 10.1.2, we're going to be dealing with triangle. So here, to prove the RT equals RQ squared over RP squared, we say that in triangle, RTQ and triangle RQP. Make a couple of observations. Observation number one is that angle T is actually equal to angle Q3. We have that angle T equals angle Q3. Why is that the case? So angle T here is actually equal to angle Q3 there. Why? Because it is the Tanker theorem. Tanker theorem. So we have furthermore that angle Q1 plus angle Q2 is actually equal to 90 degrees. Why? Right. We can actually make the observation that Q1 plus Q2 is 90 degrees. You can say obviously it is an angle in semicircle. Semicircle. Angle in semicircle. Right, so you have moreover what? But angle Q1 plus Q2 is equal to angle P. Right, so you make the observation that here angle Q1 plus Q2 is actually equal to angle P. Right, why is that the case? So we make the observation therefore that angle Q1 plus angle P is equal to 90 degrees, because obviously we can see that also angle P is actually they're both equal to 90 degrees this. Okay. Right. Moreover, we have that angle R1 must therefore be equal to angle R2 in the RTQ and RQP triangles. R1 equals to R2. The reason is that they're angles of triangle. So the angles of triangle are actually obviously the third angle of a triangle, sort of. Right. So um ideally I can do this here. I can remove the 3 so that I have a wonderful separation. A wonderful separation. Okay. The separation is therefore that this is the third angle of the triangle. Okay. Right. If this is the case, then we have therefore that the triangle, the conclusion is therefore that the triangle RTQ is very similar to triangle RQP. Why? Okay, so it's angle, angle, angle. So these triangles are equiangular. This observation makes us say that the conclusion, therefore, is that RT over RQ is actually equal to RQ over RP. RP. What is the meaning of this? So this means, therefore, by just cross multiplication, that RT is actually RQ squared, and you divide that by what? You divide it by RP. So we have done 10.1.2. Right, the next thing we're going to do now is to do 10.2. All right, if MS is actually 14 units, and also our PQ is square root of 640 units, calculate giving reasons the length of this. Right, so we continue. We continue. We continue. Right, so in 10.2, right, so we have to just calculate the length, right. Calculate the giving reasons the length of the radius of the larger circle. Right, we make first observation that QR is equal to 28 units. QR is actually 28 units. Why? Because of the midpoint. Midpoint theorem. You have RP. Right, so moreover, okay. Moreover, we have that if QR is actually 28 units, so you have that QR is 28 units. And therefore, the observation, therefore, is that RP squared must be equal to 28 squared minus the square root of 640. And then you square it. Now let's look at this. Remember that PQ is what? Is actually the square root of 640. And MS is 14. PQ is the square root of 640. And so we make the observation, therefore, that RP squared is equal to 28 minus square root of 640 by Pythagoras theorem. By Pythagoras theorem. So the observation here is that RP, if you simplify this and take the square root, so RP is actually 12 units. If RP is 12 units, we know therefore that RT is equal to RQ squared. You divide it by what? By RP from the previous results, from 10.1.2. Right, so what is the meaning of this? Right, so this means therefore if you have RT, which is 28 squared, you divide by 12. Which means RT is the same as, if you simplify this, is 196 divided by what? Divided by 3. And therefore, this means that the radius that is wanted is actually equal to 98, which you divide by 3 units. Okay, 98, which you divide by 3 units. And that is the answer. So we thank everyone for joining us in having this discussion. And the problem has been solved, and goodbye to you.